안녕하세요. Hello. iPlant industrial plant class is started. Today also I want to continue the special class of coronavirus because I was super excited with the analysis because the classification of the coronavirus was not so how to say expected that people actually reported. As you already saw that, hold on, I will show you the result first of all, and I will explain. What I heard from other people about the classification of coronavirus was just two kind of coronavirus, which is one is S type and the other is L type. However, what we saw last time, what we saw last time was that many types of the coronavirus. Okay, so I asked them, what is the variant? What is the variant? Because people are saying that there's no variant in coronavirus with regard to the clinical point of view. However, we saw that there are so many sequencer variant. We excluded the deletion. However, we observed many SMP in the coronavirus. So maybe there is so many clinical variant also, because sometimes the clinical variant is not reported because of the workload of the doctors, the medical doctors. Actually, they are really busy nowadays, and they have no time to report the variant, or they have no time to observe the the symptoms, right? So, and also you may see that the the symptom, the reported symptom of coronavirus is also not consistent to each other. So that's what I'm thinking nowadays. So maybe we can. Actually, we are not the medical doctor, so we cannot report the clinical variant, but we still can report the, let's say, sequential variant more systematically. So we don't have any prior knowledge on coronavirus. So we are actually absolutely, I say, dumb for the coronavirus. However, from the data, we can classify the coronavirus, right? Okay, so maybe this is not so good analysis, but we still can imply the classification, right? So maybe last time I missed the explanation of this plot. So TSNE1 and TSNE2. So actually I missed the labels. So TSNE1 and TSNE2. So if you search on the TSNE plot, right? Then there's so many explanation. What is the TSNE plot? So TSNE plot is a dimensionality reduction technique, which is a way to graphically simplify very large data sets. So this is very important. So the other, the mathematical explanation is too difficult. I mean, I heard that it is the concept of manifold. I don't know what that is. Manifold is the mathematical explanation that. So maybe let's read it. In mathematics, a manifold is a topological space. What is topological space? I don't know. That locally resembles Euclidean space. What is Euclidean space? Actually, I don't know. Near each point, more precisely, each endpoint, an n-dimensional manifold has a neighborhood that is homeomorphic to the Euclidean space of dimension n. In more precise terminology, manifold is referred as an n-manifold. So this is really actually not English, right? So this is, but this one. So this one. So when you think about the Earth, Earth is shaped like a ball. But if you make it into a two-dimensional way, then you can see in this way. So the surface of the Earth require two charts in this every point. Here the globe will decomposed into charts around the North and South Pole. So let's just think that maybe this kind of shape like a space is reduced into two-dimensional plot, right? So very complicated space. Actually, we don't know what that is. Maybe n-dimensional space can be mathematically transformed into two-dimensional plot. So this is t-SNE plot. Conceptually, the t-SNE plot is very similar to PCA, but some important difference. So you know what that is, PCA. So let's compare the t-SNE and PCA. So t-SNE always produces 2D separation. I don't know. So two-dimensional plot. In contrast to TCA, which can produce many different compounds. So if you have 2,000 pictures, how to say 2,000 pictures, or sometimes 2,000 pictures, or 10,000 samples, 2,000 pictures, 10,000 samples, then you can reduce using PCA into two-dimensional pictures, the principal compound, and 10,000 samples. However, you can still have 2,000 PC compound, okay? So principal compound. But t-SNE only produce two-dimensional, okay? So, and t-SNE is non-deterministic, which means you won't get exactly the same output each time you run it. So which means if you want to reproduce the result, maybe you have to, save the where is that? You have to save this t-SNE class after you feed it, okay? Then if you save this t-SNE class, then you can feed again. You can transform again the data. I think in that way. Which I didn't try yet, but I will do it next time. Okay. So, and t-SNE tend to cope better with non-linear signal in your data. So odd outlier tend to have less an impact. And often the visible separation between relevant group is improved. So this is why actually no ability reverse engineer the group it identify. So in concept you can make a probe list based on the separation you see. Okay. So anyway, so this is the third meaning. They tend to cope better with nonlinear signal in your data. So this is why actually people the single cell sequencing analysis. People who are doing single cell sequencing produce a lot of t-SNE plot. So this is t-SNE plot. So you can see this is a pretty let's say common. This is common plot. Who actually people who doing the single cell sequencing. So one sample have many genes profile. So because they do single cell sequencing, so they have so many samples and profiled by so many genes. So maybe this is non-linear. So that's why people do t-SNE rather than PCA. So PCA is not that powerful. To separate the samples by just two-dimensional. Okay. So this is why people use t-SNE. So here I also show that if I use PC compound 1 and PC compound 2, it is very hard to separate the samples. And here also you can see that many PC compound have already variance, right? So many variance is left in the all PC compound. So maybe just 1 and 2 PC compound cannot explain everything. So I used the Disney. So it just produced two-dimensional, and this two-dimensional point have a lot of information, like a flattened Earth that you see here, right? And this flattened Earth has a lot of information with regard to the positions, I mean locations, even though this is not shaped like a sphere. And we can transform the, what's that? Coronavirus sequences into Disney. So the virus length was almost 30,000 base pair, and we transformed the 30,000 base pair was reduced based on the information. So we that. So this must be, yeah, this must be the position, right? We reduced the position into 5,000, and we reduced it in 2 dimension. Okay, 2 dimension. 5,000 to 2. Okay. So this is how we. This is now what I'm explaining about the result, and we saved. I remember that we saved the Disney. Okay, so I will load it. Import pandas as PD and data frame COVID Disney. PD read picker. What was that? COVID. Right. Okay. Then we have the information 0 and 1. So this is what we made last time. So we have location, and we want to. What was the stress? What was the stress? No. What was the stress? I think I added the stress like Korea or USA. So I will remove. I will drop stress. Oh, not. Drop. No. Drop stress. No. Hold on. So pandas data frame drop. How do I use it? So I think I did it right. No. Maybe axis 1. Okay. Then in place true. Good. Let's regenerate the good. Oh. No. Let's put C1 SSB. SB scatter plot. Right? So we're gonna use the data. This one is our data. And x is 0, y is 1. So this is our plot. And line width is 0. Right? Okay. Good. And alpha 0.3. Okay. And hue would be Korea. Then we can observe the Korea here. And this must be better. No, this must be I think this is not good. So, so if you want to use this data, please ask me. Okay. Korea. Okay. I don't want to use any color, any alpha on this color. Red. Good. Then we can see the Korea position. Right? So maybe I don't want to use the scheme there. And legend. 되나? No. 안 되나? This must be brief, full, or false. What is the meaning? Let's check the Cbone. Cbones get the plot. We have a lot of times. So how to draw the region? If numeric cube inside variable represent the sample value, if full, every group will get. No, I want to add manual legend. I don't know. Anyway, maybe we have to add manually, really. And no. And we can add more stops. We can add, let's say, true, and let's say, and let's say, good. So many USA. Okay, so many USA. Good. So many USA and so many. Maybe so many. So many Europe. So many Europe. So in this case, country as Europe. EU. Okay, EU. 여기가 EU. Number 3. No? I did not. Okay. So this is what we got. So we have too many. So we have too many. Hold on. So I'm thinking that So this is how we can draw the classification that we already know. So let's, anyway, I want to remove it everything. So this is not that so pretty. So I want to just C1 scatter plot and x equal 0, y equal 1, and hue will be country. First of all, I want to just name it as country and alpha 0.3. Okay, then we can make it this way, and okay, this is okay. So this is the country, and the way we put the box out of the B box. No, let's check how to put outside of the C1. How to legend outside. So move legend outside the figure. So they always give us some answer. So PLT legend. Okay, so this is the way. Then the legend goes to outside of the panel, and let's put TX label T-SNI 1, T-SNI 2, and plot show. This is how we can plot it according to the country. But furthermore, we can use scikit-learn clustering cluster. Let's make it from and import k-means. Yeah, k-means. Oh, this is weird. Okay, let me check the k-means. Scikit-learn k-means. Scikit-learn k-means. Scikit-learn cluster k-means. sklearn cluster. 맞는데? sklearn cluster k-means. Okay. So k-means. k-means. Number of cluster, we can tell them how many cluster we have. So maybe we have how many cluster? So this is one big cluster. 1, 2, 3, 4, 5. Maybe we can just tell them 6. And number of job. I don't want to assign number of job. And then what do we have? Data frame 0,1, and bias will be x. Okay, so km peak transform peak predict x. Then it will give us this classification. So this is why it is based on random seed. So we can put some random seed, random seed, random state. Oh, okay, so here we can tell them random state. Maybe random state will be 101. Oh, then it will give us consistent result rather than changing everything whenever we learn this code. Okay, why? This is the data frame, and k means clustering will be 1, right? Good. Then we can do it again. Not country, k means. I don't know if if cluster very well or not. Still we can. All right, then it will cluster. It will cluster, and we can see the result. And because of it, because this is all the numerical value, and it produce some, let's say, gradient. Okay, gradient, right? So it produces gradient, but I don't know why it is not total 6. Rather, it just 1 over, I mean, 4 class. So because k-means cluster will give us no, set y, right? So it will give us 6 class, but it just show us okay, this then we can change it into as type string. Okay. Then no. Why? This is also country also string. This is also string. And I don't know. Then maybe I can assign things more. Apply lambda x and cluster %s %x. Good. And we can, okay, so this is really good. So this is almost perfect, right? It's almost perfect. So this is too perfect, I would say. So I want to increase more cluster. So maybe 10. Let's then now we have more classification, and we can add more, but still this is not good. This is so we are thinking that this is one cluster and this is one cluster, but k-means give us this cluster into 2 clusters. So this is not that we actually expected. So I want to change the algorithm. So if you go to the scikit-learn page, then there is so many clustering algorithm. So you can see how they cluster the results. So we can so because we are human, so we can distinguish this cluster very well by our eye. But so in this case, affinity propagation, then this circular classification is not that work properly with affinity propagation. But spectral clustering really works well for this case. So maybe we can use this spectral clustering or DB-scan, right? So I heard that DB-scan works very well. So I will use this DB-scan, okay? DB-scan, example, DB-scan. So DB-scan is like this. So I will use it like this. Okay. Okay. So where is DB-scan? No. DB-scan. Okay. DB-scan. Can y. This is the way. And we change the name to can. Can. Good. Let's see what happened. Oh, I think something is very wrong. Okay. Fit transform이겠지. Fit predict겠죠. Fit predict. 뭐야? 갑자기? 무엇이 잘못됐을까요? What is wrong? What is wrong? 아, 오케이. Good. So it gives me this much clusters. This is wrong. This is very wrong. So I may change the EPS value. So what is the EPS value? Let's see. So maximum distance between two samples for one to be considered as neighborhood of the other. So what? Maximum distance. So maximum distance. So maximum distance is 좁으면 maybe I can put 1 there. What is minimum samples? So still it is so 10. Okay, now it reduced 20. No, and 12. This is not good. Maybe minimum samples, number of samples in the neighborhood per point of view with the core point and metric default resilient algorithm. Lip size. I don't know. I do not know. This is not that very good. I don't know why. Minimum sample. Minimum sample will be 2. No, this is also not good. 5. This is better. 2. Hmm. 20. Minimum sample is 20. Okay, this is not good. That's 1, 7. I hate this type of searching around. Actually, I don't want to do it. So I changed the clustering algorithm to which one will be better? Which one will be better? So spectral clustering. Let me use spectral clustering. Okay. So spectral clustering is spectral clustering don't want. Where is the number of cluster 4? Let's see. Graph. Label. Graph. What is graph? Graph with the data. Spectral clustering. Let's go. Affinity. What? I think this is bit. Clustering. Graph. Why use graph? What is the graph? Graph is the matrix. Okay. Anyway, I will try. Split cell. Graph is not defined, but we have X. So array must be two-dimensional and square. Must be two-dimensional and square. What is the meaning? Two-dimensional and square. Then maybe we can seriously see what is the result of this code. Circuit image. Circuit image. So in looks, this command will install the circuit image. So I will install this circuit image to see how to use the spectral clustering. So after I install the circuit image, I can observe what is the data type of the graph. The graph? No, I don't know what that is, but graph data is in this way. So I don't know what is the meaning. So links. So this is the graph, image to graph. What is the meaning? Actually, let me see. This is not the one. So graph data equal. Array like sparse matrix, shape, number of sample, and number of sample. So the affinity matrix describing the relationship of sample to embed must be symmetric. Possible examples: adjacency matrix of graph, hit corner or pairwise distance matrix of the sample. Let me. Okay, so it looks like we have to use neighbor graph. So let's use this neighbor graph for making the what was that? The adjacency matrix. Okay, So let me use this information. So I don't know if this works or not. Let me try. Anyway, so we have x, and what is the number of neighbors? What is number of neighbors? So let me check. So maybe use the nearest neighbor graph as our adjacent matrix. So then we will have, so let me check if this works or not. And you can see the shape. Then, so our original X shape was like this. And so each node now have the matrix, the adjacency matrix. So this is the adjacency matrix, and let me check if this works or not. Let's see. So number of cluster is 4. We know that actually it is not 4. So, okay, so this is how we make graph Laplacian. What is the Laplacian? And find the eigenvalue and eigenvector. But he never. I don't think this is all code. Bureau. Spectral. Anyway, it takes time. It takes time, and see you again. So after learning the spectral spectral clustering scheme, it takes a lot of time, like 20 minutes, but it turns out that it is not as effective for this data set. Maybe I did wrong, but I don't know how to fix it, because actually this is beyond my knowledge about the calculation of this weird eigenvector or eigenvalue. So I want to remove this part. However, I found this neighbor graph is very, let's see, I don't know, actually I didn't test it yet, but the scheme is very interesting, because we have X data, which points our each node. What is the node? The node is a sample, and so it link the nodes each other based on the distance, right? So the number of neighbors would be 5. So it linked the neighbors based on the distance. What I'm thinking that is the correct. And we can we can return this graph based on this definition. So I copied the definition from the internet. Actually, people who are building the definition, and they upload the definition to for us to have a more convenient way. And what is the text? The text will be the word. So this is not our stuff. So we want to neighbor to graph. So this is what we want. And so our neighbor is A. So I want to change it, and I also want to remove it. And also, so maybe matrix 2 to graph, and X would be ours. And I want to remove everything. And So neighbor graph and x, right? So metric, so mode is distance, serve and matrix graph. Okay, so let's make a G matrix to graph. Let me see what happened. X. Let me see what happened. And let's import the network X. Import network X, S, and X. Okay, N is not defined, so maybe 5. So number of neighbors. Okay, we have G and next row. G. Is it possible or not? Let me check. So if this is not working, then we will coming back to k-means, because it takes a lot of time. So let me go back to k-means again and do the other analysis. Actually, I want to analyze the very well clustered labels. So I want to label every clusters, but it is not that easy, right? Maybe I want to try again Gaussian mixture again. I think this must be better than others. That's the estimation. Number of a component is 2 fit. I don't know. Let me go back to. So it takes a lot of time, so I will cancel it. Disappointed. So let me remove everything. And what was that? Y equal km. Km was km, right? So let me make it again. Km. K means number of a cluster maybe 7, and random seed is 111. What is that? Number of clusters. Okay. Km. Bit predict X and data frame. So I want to drop test. So I want to remove the previous result. Hat and km cluster. Right? Okay. So good. So this is what we got. So this is okay. So actually, I'm not that satisfied with this data, but let me increase it. Nine. 10. 10. Not good, right? 11. 12. Okay, 12 is better. 12 is better. Okay, so let me check it again. 13. 14. 14 is not good. 15. 15 looks 15 looks $16. Maybe 13 was really good, right? No? 16. Twelve, 12, 12, 20, 20, 25, 25. Okay, I think 13 will be fair enough, I think. So we have 13 groups. 13 groups, and so we have 13 groups, and we can associate the, so let me say, so Korea equal to mask and KM cluster mask and unique. 그쵸? And then we can say, okay, we have 3 clusters. In Korea, there is 3 clusters. So we can simplify. This result easily. So we have this one, this and that one and 2 clusters. Why have 11? 11 is this color. This color. This. So this also have. So this is our Korean one. Let me reduce. Let me increase the color. It's hard to see. Line with young. Line with. I think we have to so let me change the strategy again to see more clearly. So this is all Korea. So we have many things. We have 3 cluster, right? So this is right. So we have 3 cluster. So this is how we can calculate the types. So what I wanted to do was that to calculate the types. So data frame. Let's make a new data frame. Country 2 types. So this is not the clinical types, of course. So the sequential variant at and at maybe the country Korea and the number of types will be this one, right? Okay. 에휴, 정말 코드를 더럽게 짜고 있습니다. Good. And let's add USA, right? And what we have? What do we have? What am I doing? So, maybe. So we didn't make the Europe's one. Country Europe and EU. Okay, good. See, country 2 types. Okay, so based on this calculation, so this we are having just 3 different types based on the sequencing variant, and USA EU has 13 variant. Very interesting. So we are passing almost 60 minutes. So we are. Let's analyze more stuffs. So the country and location, we can increase the values, locations, unique. So what kind of information do we have? Okay, we can Brazil, France. What is the famous country? So Italia. So location, we can add Italia. the location Italia. Oh, why? No, 이탈리아가 아니고 이탈리. 무식이 들통나는 순간. Okay. Let me remove the one. 저 어떻게 없애지? I don't know how to remove the row. pandas remove index. Okay. Drop. Ah, okay. I know. drop 이탈리아. 아니네. axis 0. 이런 대문자. 오케이. Okay, then Italia have 6 types. Let me see the Japan. Japan. No. Japan has 7.1, 7.0. So this is interesting. This is really interesting. How come Japan has this much? This is seriously interesting. Number of cases will be percent D and the I int object So we have 35 cases and so Korea number of cases and so let me remove the legend. This one. Number of case. There. Cases. Okay. So from this result, we can determine that the incidence of the Korea, the incidence of the coronavirus in Korea is highly associated with each other. So it is coming from maybe China. But in the case of Japan, it's also coming from the China, and also maybe Korea or the other country. But it more associated with other countries, right? So it is also coming from China and Korea, but it's still. So I mean, I don't want to say coming. It is associated, right? It's associated to the China and Korea, but it associated with Europe or where is it? So what is this occasion? This is also Europe. So European cases are not. I mean, European cases are coming. Has come to the Japan. It looks like. This is interesting. And let me see the other country. I'm also interested in Germany. So Germany. So Germany has 10 incidents. we can add it here. Germany is like this. So North America가 우점돼 있는 highly enriched. The North America is highly enriched, and the Germany also highly enriched is plus. This is really interesting. Anyway, 이탈리아가 아니고 이탈리였죠. 이탈리. Anyway, this is so interesting that I don't know so if this is right or not. Actually, I want to see more. Where is Wuhan? Italy, Hong Kong, Singapore. Singapore also very interesting. So let me add Singapore also. Singapore also 7.1. I mean 0.0. 뿅. 싱가포레 맞습니까? 싱가포레. So this is clearly different. So Singapore and Japan looks similar, no? Looks similar. So from this result, I think we can determine some kind of signature of the data. Let me think. I think there is some way we can cluster the country based on this profile. Let me think. Anyway, so maybe next week or just by myself, I will analyze this data to cluster the country based on this profile. So this dot profile. I think it is possible, even though the number of cases is different. Anyway, okay, so this is how we cluster the data. The clustering was performed by k-means. So I also mentioned that there is so many ways to cluster the data. So it is not only way using the. It is not only way for the clustering the k-means. Maybe you can use another one, but I spend a lot of time. This spectral clustering, it takes a lot of time, but it didn't give me very good clustering. Only k-means gave me very good clustering. However, I'm pretty sure that there is another very good algorithm to cluster the coronavirus profile. So the number of types is highly differ each other, but in Korea we can say only 3 types is existing. So, but the problem is we have to say that the count, right? So we have to say that the cases, number of cases equal non we have to say this. We also have to USA. So, this is so tedious. So I will change get data. Get data in country. See, right? And so I will run this again. So get data and Korea and data. Say, USA and okay, get data 2. I will run in this way. Location. N 그치? So get data to Japan. 이탈리, 게르마니, 싱가포르. 아유 싱가포르 맞죠? EU. So we have to do it EU country 에우로페 됐죠? No. So run. Okay, so this is this is the result of our analysis. We can list up the number of types in Korea. So we have only 3 types, but the number of cases, the meaning, the number of cases is that the number of sequenced samples, right? So number of sequenced samples. So in the case of Europe, there is so many number of sequenced samples. So within these cases, there we can observe the 13 cases. But in Korea, we have only 35 number of cases were sequenced, and we observed just 3 types based on the sequences. And USA, it was equivalent with Europe. In Japan, surprisingly, it has a lot of types, but with regard to the number of cases, maybe our Korea's number of types is underestimated. In Germany, is 10 types. In Singapore, is 7 types. And we could map the group based on this T-SNE plot, and Italy. How do we pronounce Italy? Italy. Italy. Okay. Italy. In Korea, we usually say just Italia, but in English, Italy. Italy has majorly this type, right? Majorly this type. But Germany is all around the world, but major type is this one. And Japan, the major type is this one, Asia one, but the Europe type also, I say many. Korea is mainly Asia type. So this, the purple region is Asia. So most China is labeled as Asia. So let me label the Asia again. So Asia. No. Country. Is Asia. Yeah. Okay. So, oh my. This is Asia. So this Asia has a lot of cases. This is also major type of Asia, and this one. So this one and this one was the major type. So okay, so that was masked. So this one is first. So this one also Asia one. This one also Asia one. And so Italy has this type. This is the reason why there is S type and L type, right? So this is the reason why. Interesting. Okay, thank you. So I think this is the last lecture for this coronavirus. So it was really fun to analyze because actually it is really ongoing event that we can touch the data which is in public, and we can freely download this data and we can analyze by ourselves, and we can report, maybe we can report the result of our analysis even though we don't know anything about the coronavirus. So maybe people who are very special, very professional with the virus, maybe they don't like this kind of naive analysis, but still it is valuable when you do in the way of data science manner. Okay, thank you for listening and see you next time. Bye bye.